This is our universe. It is 93 billion light years in diameter. It has 200 billion galaxies, 200 billion trillion stars, and even if we assume one planet for each star, there are 700 quintillion planets in our universe. But here comes the surprising fact. This mind-bogglingly huge, vast, enormous universe started with nothing. Sounds impossible, right? Let's explore. For a long time, we didn't know what's out there or how it works. So, we made up stories for things which we saw or we couldn't understand. Later, when science came along, we started understanding better and tested our ideas based on observations. When cosmology was born, the study of cosmos itself, we really started seeing the bigger picture and started asking, what's really out there? Based on Darwin's theory, we knew that the Earth is old, really old, and it cooled down from a molten state. So it must be at least 1 million years older. Of course, our universe was older than Earth. But most of the astronomers believe that the universe was static. It is and always has been the way we see it. The universe always existed and always will. This model seemed easily understandable. But one astronomer challenged this idea in year 1912. An astronomer named Vesto Slipher, while studying the spiral nebulae, found out that these are highly redshifted. Remember, this was before we understood what galaxies were. He found out that these objects were moving away from us at a very high speed. Later, one of the greatest minds in science came along, a Belgian theoretical physicist named Georges Lemaitre, who was studying Einstein's equation dealing with universe as a whole. He found out that the equations fit better for expanding or contracting universe. And based on studies by Slipher, he proposed that the universe was expanding, which is why galaxies appeared to be moving away from us. Later, when Edwin Hubble observed these galaxies, he found out something really strange. The farther away the galaxy was, the faster it was moving away from us. This proved that the universe was actually expanding, moving away from us at a tremendous rate. But what could this mean, and more importantly, how it all started? Lemaitre suggested if the universe was expanding, it means at some point everything would be really close to each other. If we could turn our cosmic clock backwards enough, we could squeeze all the galaxies, nebulae, stars, planets, atoms, gas, everything into an infinitely hot and dense block. He called it cosmic egg. When the universe was a tiny dot, it was immensely hot, and then for some reason it expanded rapidly, like a bang, and our entire universe was born, which was big. So what could we call it? A Big Bang? The name actually came when astronomer Fred Hoyle used this word on a radio show to mock the theory. He didn't believe the theory was correct, but the name stuck, and here we have it, the Big Bang Theory. Now let's go back in time, way back, 13.8 billion years back, when our universe was infinitely hot and infinitely dense dot, a singularity. From this point, the phenomena commonly known as the Big Bang will take place, leading to the creation of our universe. Remember, the Big Bang wasn't an explosion, it was more of an inflation. Before this, let's understand some physics. When you give something enough energy, it changes its phase. For example, if you take an ice cube and heat it, it melts. This is a phase change. Heat it more and it vaporizes, turning into gas. It's still water but in a different state. If you heat it for billions of degrees, the bond between atoms start breaking apart. They collide with each other so violently that the force holding the nucleus together also breaks. You get subatomic particles, protons, neutrons and electrons. Heat it even more and even protons and neutrons start breaking apart to form quarks. As we know, quarks and electrons are the basic particles and cannot be divided further. That's what you would see if you go all the way to the beginning of the universe, when time was zero. It was filled with quarks and electrons. The universe was so hot that even the basic forces that we see today, gravity, electromagnetism, and two nuclear forces responsible for holding atomic nuclei together, were all squeezed into one unified super force. Now, our physics cannot really answer what happened in first 10 raised to minus 43 seconds after the Big Bang. But we have figured out the entire existence of the universe after that. So it's okay, I guess. In 10 raised to minus 36 seconds, the universe expanded rapidly. It grew from the size of an atom to the size of an orange. After 3 minutes of the Big Bang, the universe expanded and cooled even more. The subatomic particles fused to form nuclei and created the first chemical element in the universe, helium. This fusion phase stopped in the 20th minute, and when it did, there was 3 times as much as hydrogen as helium in the universe. And this ratio is pretty much true today. The sun is 75% hydrogen and 25% helium. The next big event happened when universe was 380,000 years old. The universe was still hot before this, so electron couldn't bond with nuclei. But at this moment, the universe cooled enough that electrons could combine with proton and helium nuclei. And we had our first stable neutral atoms. We call this recombination. Before recombination, there was light, but it couldn't move freely since electron would suck them up. So the universe was opaque. After the recombination, photons were free to fly. The universe became transparent. Why is this important? Because the light emitted at this point is what we see as the cosmic microwave background. This light has been on the journey to Earth for 13.8 billion years, fighting the expansion of the universe. This light is important because it tells us what our universe was like a few thousand years after it was formed. The matter was evenly distributed throughout the universe, and it had the same temperature everywhere. The universe was smooth, and something happened in the universe for it to be this smooth even after hundreds of thousands of years after the Big Bang. This is when theoretical physicist Alan Guth came up with a groundbreaking addition to the Big Bang model. At some point in our universe, the expansion suddenly accelerated. The universe got bigger by 100 trillion times in a matter of a fraction of a second. We call this inflation. This explains why the universe was so smooth during the recombination. Space expanded so rapidly that it evened out, like pulling the blanket. Then, things went pretty still for a while. It took about 400 million years for hydrogen atoms to fuse and make the very first stars. Another billion years passed and the gravity began pulling matter closer, forming first galaxies. Our Milky Way galaxy began in the same fashion around 9 billion years after the Big Bang. And there you have it, creation of our universe started from nothing. There are still many unanswered questions. Were there universes before our own? Is this the first and only universe? What started the Big Bang? We don't know, and maybe we never will. But what we do know is that the universe, as we know it, started here and gave birth to particles, galaxies, stars, the Earth, and you. So let's keep on exploring until there are no more questions to ask. If you enjoyed this video, make sure you hit the like button, and to watch such more content, subscribe to our channel. See you again very soon. Till then, keep exploring.